So for homework tonight, you're basically going to be doing the 1-1 goes, and it's all about finding the slope of a line. And I want to talk briefly a little bit more about slope from the review. Slope, what is it? It basically is a number that determines, right, how steep a line is. Oh, sorry about that. And there are basically 4 types of slope, right? So if we draw the coordinate plane and then we put a linear function in here, if I look at the following line, this is a line with a positive slope. As you go up from left to right, that's a positive slope, right? If you go down from left to right, okay, that is a negative slope. So right away, this would have a negative slope. If it's perfectly horizontal, remember, it determines the steepness of a line. If it's horizontal, it has no steepness, so your slope would be 0. Now, a vertical line, what you have to understand is if a line has a slope, you should be able to walk on it. Can you walk up a vertical line? No. So this has no slope, or a lot of times we say the slope is undefined. Okay? Now, some other phrases that cue you in on slope, right? Rate of change is 1. And you also know that rate of change is the same as your common difference. And the symbol we use for slope is the letter M. And we say it's basically the rise over the run. Okay? And think about it, when you're rising or falling in the coordinate plane, what is changing, right? If you're going up or down, that means you're changing the y value. So it's a change in y, and this little triangle means change in, right? The change in y over the change in x. So what I like to say is we just subtract the y's over, we subtract the x's. Now you've seen some teachers do the x2 minus x1. Those little sub numbers basically just tell you the order in which you should subtract. And as long as you keep the order the same, it doesn't matter which ordered pair you start with when you subtract them. Okay, so let's take a look at some examples here. The first one, if I look, here's x, here's y, here's x, here's y. Now when I go to find the slope, I subtract the x's over, I subtract the y's. Does it matter which one I start with? No. If I start with this ordered pair, when I subtract the x's, or the y's, I must start with that ordered pair when I subtract the x's. So if I do 5 minus 9, right, since I started here, when I subtracted the y's, I must start here with the 3 when I subtract the x's. So it'd be 3 minus negative 2. But when I subtract a negative, what's it become? A positive. So 5 minus 9 is negative 4, and then 3 plus 2 would give me 5. Now if I calculate the slope the other way, starting here now, right, 9 minus 5 over negative 2 minus 3, I would get 4 over negative 5, which still ends up being the same answer. So as long as you keep the order the same, it does not matter. Keep track of your negatives, because if you subtract a negative, you have to remember it becomes a positive. So when I go to find the slope of example 2 or 3, the first thing you have to do is find 2 nice points. When we talk about 2 nice points, we're looking for the intersection of 2 of the grid lines with the graph. So right away, this line has several nice points. That's a nice point. If I go up this line, oh, there's another nice point. Here's another nice point. Here's another nice point. So what I could always do if I wanted is I could take the ordered pairs. So this would be 0, negative 2. This would be 3, 0. And I could go ahead and use the formula. Subtract the y's, negative 2 minus 0, over subtract the x's, 0 minus 3. That gives you negative 2 over negative 3. And when you divide, or when you take a negative and divide it by a negative, you get a positive 2/3. So that's one way you can calculate the slope, is pick any 2 points and use the slope formula. But remember we said slope is also the rise over the run, the change in y. So right away, if I wanted to take a journey from one point on the left to a point on the right, what is my rise over the run going to be? So if I track out from here to here, right, how many units did I go up first? I went up 2, and I went over 3. So here's my rise, here's my run, therefore my slope would be my rise 2 over my run 3. Remember, we always take a journey from the point on the left to the point on the right. So over here, up 2 over 3, you get the same thing. So when we go to do the next one over here, I'm first going to find all the nice points. There's 1, there's 2, there's 3. As I go down, there's another one. So I pick any 2 points, it doesn't matter. So if I want to use, I'll do these in black. Right, if I want to use this point and this point, I'm going to take my journey from the point on the left to the point on the right. And I always move up or down first because it's rise over the run. So m equals, here, since I'm going down first, my slope is going to be negative, and it's 1, 2, 3 over 1. So in this case, I went down first, so it's negative, and I wrote right 1, so my slope would be negative 3. Okay, and if I look here, down 1, 2, 3 over 1. So no matter what, my rise over the run is always down 3 over 1. Rate of change for a table now. Remember, we said slope is another word for rate of change, which is another word for, right, your common difference. So here, what is my common difference? What is happening each jump here, right? From negative 8 to negative 2, I went up 6. From negative 2 to negative 4, I went up 6. And up top, what's my change in x? So my change in y, right? My change in y over my change in x. What is my change in y? I went up 6. And then my change in x is over 1 or up 1. So my slope is 6. All right, so it's basically your common difference. If I look at the next table, here's the thing. What did I go up here? I went up 5. What did I go up here? Up 5, up 5. So right away, change in y over change in x. What is my change in y? Plus 5 or positive 5. My change in x, though, if I look, my x values, I went up 3 here. I went up 3 here. I went up 3 here. So right away, my change in x is up 3. So my slope is positive 5/3. Now, I could also take any 2 points and use the slope formula. I could do 25 minus 30 over 9 minus 12. That would give me negative 5 over negative 3, which simplifies to positive 5/3. Okay, so hopefully this review of slope is a good refresher. And tonight your homework will be the 1-1 to 1-3, or sorry, the 1-1 ready, set, go.